So in this lesson we're going to review multiplying and dividing radicals. And this box that we have here pretty much summarizes what you need to do when you multiply or divide. Always, the most important thing you got to remember is that you do have to simplify in the end, but I recommend multiplying first or dividing first and then simplifying. So when we do this, we want to multiply and divide the coefficient and multiply and divide the radicand, which is the number under the radical. So what I mean by that is if I have 3 radical 2 times 5 radical 7, we're not going to multiply everything by everything else. We keep coefficient with coefficient and radicand with radicand. So when you're done, you're going to multiply the 3 times the 5. And that's going to be your final coefficient on the outside. And then on the inside, you're going to multiply the 2 times the 7. So in this case, you'll get something that you can't simplify any further. It's 15 radical 14. So that's the process. Multiply the coefficient, multiply the radicands, and then if possible, simplify to lowest terms. So let's take a look at the different examples. Now, a lot of kids will want to try to simplify the 60 first and then multiply, but you're much better off multiplying first. The coefficients in this case are both 1, so I don't really have a coefficient on the outside. That's not going to change. It's going to stay a 1. So then I multiply the radicand by the radicand. The 60 times 6. I'm going to show the intermediate step, but when you do these problems, you don't have to do that. This is the intermediate step. That's going to give you 360. From there, we're back to our simplifying. You find the largest perfect square that goes into 360. That's going to be 36. And the radicand is 10. And then in the final answer, again, I take the square root of this perfect square. So my final answer is 6 radical 10. So in the end, the process ends up being the same as it used to be. In the second case here, I have radical 96 over radical 4. Again, you would divide coefficient by coefficient, but since they're both 1, your outside coefficient is going to remain a 1. And then 96 divided by 4. We can divide radicand by radicand because I can rewrite it like this. The square root of 96 over 4. When I do that, 96 divided by 4 is 24, and then that can be reduced. Radical 4, radical 6, which in the end gives me 2 radical 6. Now some division problems look a little bit different, or they operate a little bit differently. Take a look at the second one here. The square root of 17 over 25. I can't evenly divide 17 by 25. But what I can do is separate out the radicand. So I can have radical 17 over radical 25. When you do that, 25 is a perfect square, so I can take the square root of the denominator. And in this case, my answer is going to be radical 17 over 5. We always leave our answers exact. We don't put in decimals. I would not take 17 and divide by 25 with my calculator. This is the way we want to leave the answer, in lowest terms with the simplest radical. Okay, so the next one, we're going to add a variable in here. So when I multiply, again, my coefficients are 1s, so it's going to stay a 1, and then I multiply an x by a 4x, and under the radical I get 4x squared. That happens to be a completely perfect square, because the square root of 4 is 2, and the square root of x squared, remember, with an even exponent, we're going to divide it in half, and I end up with 2x. Now the next one is finally an example of where I have coefficients in front. So I multiply the 4 times the 6, and that's going to be 24. And then under the radical, I multiply the 30 times the 3, and that's 90. Then I want to reduce the 90. So the 24 is going to stay there until the end. I have 24. And then I separate this out into the largest perfect square. Well, the largest one that goes into 90 is 9. And then the leftover radicand is 10. So I have 24. I take the square root of 9, which is 3, and I'm left with the radical 10. So this gives me 72 radical 10 when I'm done, because what you do is you multiply the 24 by the 3. So you multiply the coefficients, To get the 24, you multiply the radicands. To get the 90, you separate the 90 out into 9 and 10. You take the square root of the perfect square. He's a 3. You multiply the 24 by the 3. To get the 72, the radical 10 stays radical 10. Alright, so here's an example with of dividing with coefficients that are greater than 1. I divide the 16 by the 2, and then I divide the 20 by the 5. So 16 divided by 2 is going to be 8. 20 divided by 5 is going to be 4. And again, a lot of kids will take that 4 and try to put down immediately 2 radical signs, because that's what you're used to doing. But think about it. 4 is already a perfect square. So if I were to separate it out, really it would be radical 4, radical 1. But 1's also a perfect square, so that process is really redundant. The square root of 4 is 2, so you end up with 16. Alright, well, when we work with different problems, we don't like to have radicals in the denominator, because it means you're dividing by an irrational number. And we just don't like to do that. So what we like to do instead is we like to rationalize the denominator. So this is a process I'm going to show you here. You basically are not allowed to have a radical in the denominator, so we want to rationalize it. The steps are given, and the first step is to check and see if you can divide the numerator and the denominator to eliminate the radical. So let's look at our example 1 here. I have 1 divided by radical 2. That's not going to work. So that's not going to reduce down to a whole number. So can't do that one. But if you could, that's what you would do. If you can't eliminate the radical, you got to do this rationalizing thing that I'm going to talk about next. Basically, what you want to do is, I want to multiply a radical 2 by another radical 2. Because when you multiply radicals, or when you square a radical, which is when you multiply a radical by itself, you're going to get the radicand as an answer. I'm going to show you that in just a minute. But in order to multiply the denominator by radical 2, I need to multiply by the equivalent of 1, which means I need to multiply by radical 2 over radical 2. So I take 1 over radical 2, I multiply by radical 2 over radical 2. That leaves me with radical 2 over 2. Here's why. Radical 2 times radical 2. That's going to be radical 4. The square root of 4 is 2. So when you multiply a radical by itself, you get the radicand as an answer. Let's look at the second one here, radical 7/5. I can break that up into radical 7 over radical 5, because 5 will not divide evenly into 7. And then, again, to rationalize it, I'm going to multiply top and bottom by radical 5. What that leaves me is 7 times 5 is 35, so I have radical 35 in the numerator and 5 in the denominator. You cannot divide the 5 into the radical 35. This is an equivalent answer to radical 7 over 5. All we did was change it. It has the same value, but we changed it so we don't have this radical in the denominator. So I'm going to demonstrate that rationalizing with a few more examples, and then I'm going to leave the final 2 area examples in your notes to do for class. So these examples aren't in your notes, are not in your notes, but you can find, if you turn your notes over on the back, there's some blank space there. We can do a few more of these. So here's another example. If I want to rationalize, let's just say 5 over radical 2. Again, I can't divide the radical 2 into the 5. So I'm going to multiply top and bottom by radical 2 over radical 2. And then in the numerator, I'm left with 5 radical 2. And then in the denominator, I'm left with 2. So when I have a coefficient and a radical, if nothing divides out, you're going to keep that coefficient, but then your radical is going to move to the numerator. So it's 5 radical 2 over 2. In the next example, I'm going to have a coefficient in the denominator. So let's say this is 7 over 2 radical 3. Well, I only need to get rid of the radical part of this. The 2 is okay. So it's the radical 3 I got to deal with. if I multiply top and bottom by radical 3 over radical 3, that's going to give me 7 radical 3 in the numerator. And then in the denominator, I'm going to do this in steps. Eventually you'll get good at it where you can just do this in your head. My coefficient of 2 stays there. When I multiply radical 3 times radical 3, it simplifies to 3. So, in this case, I'll have a product in the denominator. And my final answer is 7 radical 3 over 6. That's how you rationalize. So, multiplying and dividing should be reviewed from last year. And then rationalizing might be new. It all bases on the fact, the rationalizing part is dependent on the fact that when you square a radical or when you multiply a radical by itself, no matter what radical it is, you're going to get the radicand as an answer. So radical 17 times radical 17, just going to be 17. Okay? Radical 5 squared, that's the same as saying radical 5 times radical 5, just going to be 5 when you're done. So that's what this entire process is based on. So we will work on more of that in class. And in class we'll also look over the area and the width problem. That's in the last page of your notes.